All right. This presentation, I'm going to talk about a system which is a combination of different functionalities, different packages that translate natural language commands, domain-specific languages, from domain-specific languages into specific computational workflows. I would like to show the general strategy and the software architecture, some examples, and an important part of this is how is this kind of results are also presented to the end users. What you see right now is a Mathematica notebook. I have connected that Mathematica notebook to Raku. I'm going to explain. Here is a little bit about me. I'm from Bulgaria. The reason I'm mentioning this, I speak Russian very well. Someone with my background, mathematics and programming, we just know Russian. But Bulgarian is actually kind of closer to English. So many of these grammars I'm going to show, which are in English. For me, it's much easier to translate from English to Bulgarian. And I missed an important statement here. Bulgarian is analytic language. It belongs to the Slavic languages mostly because of the vocabulary, but it is actually quite similar to English in many ways. So I'm looking into a multi-language system here. So after I made my PhD in large-scale air pollution simulations, I worked for Mathematica, both from research. I'm a big fan. It might be seen later on. So what is this about, or what is the motivation for this system? I do want to do rapid specification of prediction workflows. When I say prediction, I mean anything related to, say, data science or computation, scientific computations, like say large-scale air pollution simulations, epidemiology. There are many packages and languages that can be used to do computational workflows. But usually, if you know what you're doing, you're basically following the same workflow. You just need to figure out all the different details and idiosyncrasies for the different languages and different packages. My target audience is not just people off the street. My target audience are data scientists or data scientist wannabes or data analysts, and also people who do scientific computing and so forth. Some of these people were probably engaging in this kind of activities part-time, but some of them are doing full-time. So what is this? So here's an example. I'm not sure with this audience, what is the interest into data science or prediction, but this should be an example that tells everyone something, like this computer science. Like, let me just show what I'm evaluating here. So I have some sequence of natural language commands here, and you see I'm translating them into different programming languages with different packages in them. Very interestingly, many packages, like say in R, there are like say 4 or 5 different packages for doing data wrangling. Obviously, if I can do this for a programming language, I can do it for another natural language. So here I need to probably post this into the chat. If you want to experiment with this, you can actually. This is an interactive interface. This is Shiny Apps, right? So if I want, like, I'm going to go to some of these examples here. I'm going to pick some of these examples and copy and paste it here, right? And then I'm going to press submit, and I'm going to get something back. If I want to parse it, at least at this point you should believe me, but this is a valid R code. I would like to describe what is happening here. Basically, I have a server in DigitalOcean, and I'm running crawl in it, and with different packages, which interfacing different packages in this system I'm describing here. And I can interface that to, say, notebooks or Shiny Apps or whatever, right? Right now, what I'm showing in my presentation, it does not use a web service. I can, but I don't. I use I run Raku locally on my computer. And so I see this is a longer description. I would like to reiterate that this system is a multi-language system, both from the perspective of the input languages and what is being produced. Now, the interpreter here is in Raku, right? What I'm showing here is in Raku, but it doesn't need to be, right? And so it can be in some other language. I did started doing this in other languages, not Raku, but I moved to Raku because Raku is just more convenient, you know, very nice, very convenient to deal with grammars. So another thing to mention, this is not prediction with Raku. This is Raku for prediction. So I'm not making the actual computational workflows. I'm not executing them with Raku, right? I just translate natural language commands into software code, right? So this is what is happening here, right? I'm not executing this, right? Like Raku just produces this programming code. And there's some other perspective to see here. I mentioned here this principle, the clothes have no emperor. So this phrase was used by Tony Hoare. He was in his Turing Acceptance Award, and he was characterizing Ada. He was mentioning it more on a negative connotation, but in my opinion, this is kind of a positive thing because this actually makes the system more universal. This kind of approach, and to some extent, I'm going to would like to show this with this diagram here. So Raku is basically utilized here, right? It doesn't know that much about this is a conversational agent for food preparation workflows. Like say you want to say I want to cook 10 Greek dishes in the next 7 days. You know, so you want to get some kind of back some kind of recommendations or some kind of directions, or you're saying, I want to cook Thai food, give me directions for, say, chicken pad Thai or something like that. So anyway, this system doesn't need to know these databases that much. The computations happen somewhere else. It can be, but it doesn't need to. And one of the consequence here is that if I have designed this system in such a way, this means that when people want to use their own proprietary algorithms or data, the system itself doesn't need to know about it. I can give I plan to give a bigger, larger example on this engine later on. So I would like to mention here what I consider to be the ideal end result. Well, obviously, you know, interactive environment like this with notebooks and appropriate context being associated, web services and IDE plugins. Imagine you have an IDE plugin which actually can translate natural language commands into whatever kind of code you're doing, say you're programming in Python or whatever. So this is something that I was thinking to give a live demo, but I don't have to. You can see here with this natural language commands, I've been generating different programming code in different systems. Well, this is another reason I'm using Mathematica and this Mathematica notebooks. Mathematica has actually a very nice multi-language evaluation cells, right? So the notebook technology from Wolfram Research allows me to hook up to many different languages if I have to. I had to do the hookup with Raku myself, and I'm going to show this this later. So usually when I describe this system, and I'm not describing usually the system from architectural perspective, more like kind of how to be used and, you know, like what are the data scientists workflows and etc. There are several questions and very important questions which I'm being asked. So why I'm using natural languages? Natural languages are not precise enough, and to some extent, you know, like it's probably not that useful anyway. It's like, I would like to have some kind of hard executable piece of code. And I was like, yeah, sure. From another perspective though, natural languages are more abstract, right? And so if that's why I'm using domain specific languages. There's some abstraction and some kind of restriction of the language. The other is why I'm using grammars. This is what I'm doing here. I'm using grammars. And here I'd like to say, I forgot to mention this. I have 3 panels. In the central panel is my presentation. In the panel to the right is, you know, additional notebooks or things I want to show. And this panel to the left is, I have a panel with Raku code, right? And so, so what I was saying, and since we're discussing, I was mentioning scientific computing, epidemiology, and so forth. So this is how I do this computational workflows, right? I do have grammars which specify with which I can specify the computational workflows, and then I translate them concretely to some language. Like say, you can see here, you know, after I have parsed the concrete commands, I am translating it to concrete code, right, which can be, say, executable later. So, so they're asking me why I'm using grammars and Raku and so forth, why I'm not using some of the stochastic algorithms, stochastic neural networks, and whatever kind of methodologies related to that. Well, the question is, when do you get precise results? Using this kind of systems, it's ultimately on heuristic. And with grammars, I can guarantee some concrete results being produced, but also the system tends to be much lightweight. Another question is this a product? Well, I don't know. It's not a product. I would say it can be turned into a product. It is in the same way how Unix is not a product. Unix is more a place you know, but facilitates your experience with the resources of whatever computers and programs you have at hand. So similarly here, this system is more of a facilitator of using data science and machine learning algorithms or other computational algorithms. So more or less, I basically gave answers to the questions here, and again, and we'll return to this. So what we're seeing here right now, what I'm going to be showing, this is something like what you see in this notebook. So I started a Raku process, and I closed the socket with this Raku process using the library 0MQ. So basically, so right now on my computer, Raku is being run, and the examples I'm going to show and the examples I already showed, they're basically making this. I'm executing when I put something in some Raku cell or some kind of evaluation command, which translates the natural language. I am going through 0MQ to my Raku session, and I'm using a particularly sandboxed Raku REPL object. I can be a little bit more specific here. So this is what is this package. I submitted it to POS. So yeah, you can see here I'm basically having some REPL object here, right? And when it is being used, right, it's the evaluation routines. They're using one of these functions called chunk evaluate. And so yeah, we're basically some. At some point I'm going to be using this sandboxed REPL to evaluate the code and get back the results. All right, so this here, I mean, more or less, I'm explaining, you know, what a different perspective on this. But I was very interested in connecting Raku to notebooks, and here is probably I'm going to use the opportunity to engage with some of the presenters from you know, the previous presentations, like say Daniel Sowell, where you know there's some discussion about from him and some of his blog posts about literate programming. So this is related to that, right? I'm very interested in literate programming, and one of the ways for me to do it is to endow Raku system or the other way around, notebooks with the ability to connect to Raku. And so this kind of connections, in order to do it, yeah, I had to develop this kind of package. And also that package is also used to, if I have some markdown document, if I want to evaluate the cells of that markdown document, I can do that through in that way, right? So I'm going to show something which is related to that. Like say, if I have some kind of document like that, I want to get these results. And so this kind of system, in order to preserve the context between the different cells, I have to do some kind of sandboxed Raku REPL and so forth. That's very similar to how Jupyter works and how actually Mathematica connects to the external evaluators I was showing earlier. So here, I mean, I can show you here, I'm going to make a Raku cell, and I apologize, I didn't check this, but it looks, but it just doesn't look that well when it doesn't look that magnified, you know, in my presentation mode. So anyway, here is just to convince you what this is, you know, I'm connecting to Raku here. So much of the things I'm showing, they can be seen, this package, which I'm demonstrating here, which is lingua numeric word forms. It translates spoken word forms of numbers into actual numbers, right? So this here, it's as I said, this package actually demonstrates quite a lot of the things I want to do, especially this part here of being multi-language. I'm actually translating forms from different languages into numbers, and so going back to this slide, you can see, for example, here I generated some numbers in Bulgarian and Japanese using Mathematica functions, and I took these word forms here. I gave them to this Raku evaluator. Now here is the process. This process here, the Raku process, this is the one which is running in the background, and this is the socket I have closed with that process with 0MQ, right? So if I go back to this part here, this is what is happening, right? And right now, in this, when I close that socket or whatever, right? I'm running 0MQ there. It's if I want to show you how exactly actually a fairly concise program, which all right, something is not. I'm getting some messages here, but my it's unstable. My connection is unstable. Let me show you what I was saying, what I was threatening to show, but how Raku is being utilized for this. It's this kind of short program. You can see I'm using this 0MQ, whatever, and I'm having this kind of listening part, right? And after I get some message through the 0MQ pipeline, I evaluate it with this with the package, this text code processing, right? This code chunk evaluate, and then I return the result. All right. So what I'm saying is that this here, right? This is what is happening right now. So in some sense, this package has all of the elements of what I'm looking for in the whole system. It's multi-language. I need to manipulate. I need to deal with multiple languages, natural languages, and I want to translate them to code. In this particular, the code is just some numbers. All right. So there are several things to decide upon when such system is being made, and some simplification assumptions need to be made, and some probably some kind of design principles need to be spelled out. In this particular case, my simplifications, but I am actually using grammars, and as I said, I am talking to people who are technologically minded, and so I'm not talking to people completely off the street, so to speak. And the other is what the grammars I have in mind, and I'm going to switch to this demo panel here, and I need to refresh it because this is running on the Shiny apps, right? So in this particular case, what is happening? Shiny apps connects to DigitalOcean and serves this code. So anyway, if I show you the examples here, some of this I mean, first of all, I assume that people know what we're talking about. Second, I do assume that the grammars are given in this kind of form, and more or less that's it here too. I mean, I would allow people to say misspell stuff, right? So if I do that, I can still produce some code, and so here in the errors, this might tell me, look, I mean, you're misspelling a statement or whatever. But in general, I do expect, this is the system is for people who know what more or less what they're doing, or have very technologically minded. I'm using the so-called pipelines or monadic pipelines. This is a very important part of the whole thing, in a sense, using monadic pipelines to specify computations. It is something that I see to be easily translatable to natural languages and vice versa. Because of this, the whole system is kind of relying on this, but this is also a Unix principle. In Unix, for example, we do use the pipeline operators. Unix, it's one of the explicit principles in Unix is to have new functionalities or new functions to be more like filters, which transform textual outputs, right? And so this is something, as I said, this is something that I'm using a lot, and I'm trying to leverage as much as possible. I'm going to give a demonstration about this. The complete feature set. Well, it's not complete here, but it does show some of the structure of these packages. There are packages which are shared. They're shared roles, shared utilities. I am writing big part of this grammars I wrote there in English. I am working right now on translating them to Bulgarian. Most of this data science workflows or data science computations, most of them, they belong to some combination of three or four type of workflows. And so I have spelled out here, I have missed one because I haven't done good efforts on it. It's classification. So I would claim that, say, 70 or 80% of all data science and machine learning workflows would include the data wrangling, regression, recommendations, related semantic analysis, and classification, which, as I say, is missing here. But you can see I'm targeting different programming languages and different packages in those programming languages. All right, so this system has three types of packages. There's a core computational workflows, like, say, related semantic analysis and or like classification or recommendations or data wrangling. I do have packages for name entity recognition and metadata recognition. I'm going to show what it is. Well, actually, I can show it right now. So here I'm going to show the so-called geographics package, right? So you can see here I have a package which just recognizes geographic locations and names and related adjectives or whatever it is, And so that recognition, I also put it through some grammar rules, right? So I can actually utilize, I can specify presumably large number of entities here through my resources files or whatever, and then use them, use this type of package to do name entity recognition while I'm parsing, some grammar commands and so forth. So I would say there's another part here which I missed. These are the utilities packages, like say which are more central, like say this number recognition, spoken word forms number recognition package is on the utilities side. So, and you know, all the packages which or functions which recognize misspellings. All right, so this here shows, I'm not sure how informative this is, but this kind of shows how this the packages I have developed so far in this system, how they depend on each other. One of the things recently I mentioned, I was asking this kind of question in Stackoverflow, how I can find all classes which are in some namespace or some package. It's related to that. I want to, instead of this, when I hover over these packages, I wanted to not just say show you the package name and what it does, but also show, you know, like say UML diagrams, you know, with all the grammars and etc. Well, maybe in the future I'll do that. I'm going to move to an example of how I develop this type of packages. So here I have this flowchart describes transformations over tabular data, like say tabular data sets, right? Like data frames, they're called, or whatever, right? Like think about CSV files or Excel sheets or whatever it is. So majority of this, like sometimes to make certain transformation, we go through this pipeline several times. I'm not going to expand on this, what exactly is being done, but basically I'm saying, okay, well, after I have programmed this, I do program, let me see, this should be live. I'm going to program the, yeah, this executed is just, I need to show it here, show the result. So I'm saying, all right, well, I'm going through this pipeline, right? I'm seeing what is the shape of the results. I'm doing some filtering like this delete missing, and I'm doing some kind of splitting of the data, transforming the individual groups, combining the groups and doing reshaping. More or less, this is what is happening here. I have deleted the missing parts. I have filtered the data, and I don't do grouping, but I do reshaping. I do cross tabulation of passenger class and passenger survival over passenger age. So basically, yeah, this is the standard Titanic data I should have set. So we have nearly 1,500 people with different passenger class, passenger age, sex, and survival. And so here, this transformation just tells me the male passengers and the who died and the people who survived, whatever, some kind of weird filtering, how exactly I'm going to, I mean, I want to see the summary age for whatever reasons. Now, this actually, look at, if you look at this code, and I'm not sure how this seems so, I'm going to get it out of here and just put it in a text box, right? If we look into this code here, it's actually, this specification is fairly concise, but if you look at the commands here, right, for the actual language, there are quite a lot of symbols to be added, which if you know the language, that's fine, but you know, it can be arbitrarily seen as arbitrarily idiosyncratic. Similarly, this is another example with related semantic analysis workflows. Again, I developed some sort of workflow diagram. I have the workflows in mind. And then I developed the actual grammars for it. And here, yeah, you can see some, this should be live. I mean, basically, this here with these commands, I'm generating this natural language commands, I'm generating this code. And, you know, then, yeah, basically, this is it. All right, so, yeah, as I mentioned, this is also, of course, scientific computing. This here is from epidemiological simulations. Let me see if I can evaluate this. And so anyway, it's, yeah, okay, right, evaluate it. And I'm going to evaluate this whole thing. So, right, I mean, one of the reasons I'm showing this example is that this conference is being done online because of COVID-19. But when I say prediction, I don't mean say data science and data wrangling only. I mean also scientific computing like that. All right, so this is well, how it's actually done, right? And it's an interesting question. I would say I already spelled this out a little bit, but I'm developing packages for the scientific parts, right? For the scientific elements, and then I'm developing the grammars. At some point, the grammars and the grammar outcomes, right? The translation of grammars into code and the actual code, they're connected into something, and then this something basically is presented into these notebooks and other interfaces. Right now, I'm making single line interpreters in some sense, but obviously I can do some higher order parsing and interpretation. At some point, we can connect this to some system like Alexa or Siri or whatever, and produce some results. Another thing here, before going further, rigorous testing is being required. Because I'm using monads, actually, I would say monadic pipelining is very conducive for doing some random tests, and this is something Vadim Bellman mentioned. He's interested. I'm using quite a lot of randomized tests to test the monadic implementations. So I already mentioned the monadic pipelines. If you haven't seen the monadic pipelines before, here now you can see this monadic pipeline, but basically it's saying, look, I mean, if you have some assignment here, like say with Python, right? Why use this object, you know, like mentioning it all the time? You actually can have it explicitly being used. And people who know Raku, they know the pipeline symbol in Raku, so I don't need to expand on this. So this is what I was saying, but with pipelines, why I'm using pipelines. So I'm going to evaluate here this in place, and you can see this command right now. So this quantile regression workflow code, this is going to my Raku session, right, and translates it. And so one of the reasons to use monads is that your code has algebraic structure in it, right? And so it's actually this kind of translations, it's literally, this is what is happening when I actually do the executions, right? So I actually can transfer translate any of the pipelines separately. And so, for example, or whatever. And so because I have this guaranteed algebraic structure into the code, this is actually translating sequences of natural language commands. It's actually fairly easy, fairly straightforward, and more reliable than using something else, right? Sorry, I meant to go to another slide. As I mentioned, I'm using grammars and from Raku, and basically this, I mean, I don't need to convince this audience how useful grammars are. I've been using grammars in with other systems. I moved to Raku because that's much more convenient. The rigorous testing part I mentioned, of course, right? So, right, when I'm doing this kind of, say this is for data wrangling, when I'm doing this kind of development, I do make Raku tests for the actual grammars, but then for each of these packages and languages, I need to actually make run tests, right? It's not just say, have I parsed the sentences in the commands, but these sentences and commands, when they interpreted the actual code the system produce, is it something that it's produces valid results? And so I can demonstrate this here. For example, in my, I just clicked on that link somewhere here, right, with these tests, right? I mean, I'm going to, let me see, I'm going to show that how I'm using these commands, right? Then I translate it into code, and then when I evaluate it, I produce something where it's expected, say. So I have lots of, I need to do this kind of tests quite a lot. So the server solution, I already demonstrated that. It's pretty straightforward. As I said, I can use it inside here, right? And ultimately, this is what is happening. I get some kind of commands, this translated into some URL, and then it's being invoked. I'm not doing this in this notebook, as I mentioned. I'm connecting to Raku directly. Yes, I connected this to different notebooks. That's entirely possible. What I was showing you here, it's here with this example is the Shiny app part. So I mentioned this, that concise commands can produce lots of code. Very often people tell me, okay, well, my approach doesn't, it's more complicated than that, then your workflow is fine. But you can still use this system to produce probably 60 or 70% of your code. So I am using a fairly minimalistic approach to some extent. That's why I'm using Raku and grammars, right? And yeah, using pipelines, but more about philosophy, right? In some sense, big part of this system is adhering to this 17 Unix rules, which was spelled out by Eric Raymond in his book, The Art of Unix Programming. And so, like, for example, yeah, writing small programs, writing transparent programs, and so forth. You know, like, I'm not, when I say transparent programs, my programs, the programs I generate are transparent, but the actual generation, not that transparent. That's why it's marked as no. Are they robust programs? Well, I do try to make them robust for sure, right? In there, some principles like say, don't make the data complicated, not the program. This can be, I mean, I can do some hand waving and tell you I'm adhering to this, but maybe I don't. So, you know, it's like, but most of the other principles I would claim I follow them fairly closely. Here, this, why not use gptm, BERT, and etc. Well, actually, I prepared some example. Let me see, should be able to invoke it here. And so, yeah, like, let me see. Yeah, well, I'm not going to venture much in this, but all right. Yes, it's an important thing to know what is the alternative and how we behave with the alternatives. And you can see here, I'm going to show you this uses some neural networks and extracts some parameters, right? And in these parameters, it basically, it got this result, but it's pure, it's stochastic, right? It's extracted the parameters. I'm going to do something else though. I'm going to say 12 values and I'm going to period, right? Now, although this is extracting, you know, things in some way, I mean, you can actually, it just doesn't, you know, this, for whatever reasons, the column name generator don't work, right? And so there's some other, you know, stuff like that. And you know, when you use this kind of systems, it's a question. You need to, it's a heuristic, and at what point you actually start massaging the results and trying to produce something better. And then if you start doing this kind of massaging and transformations of the stochastic results, are your cross-processing going to be valid for the next versions of those systems? That's not a given. And so since we're going out of time, I'm going to speed up my presentation. I am not completely against the stochastic methods. I think they need to be combined. This is the Terminator's analogy. So right now I'm doing the hard skeleton thing by Schwarzenegger. There's the liquid metal, which is the perspective, which is the stochastic one. And of course we can combine the two, like the Terminatrix by Tristana Loken. I did mention that if I can do this to a programming language, of course I can do this to another natural language. I did mention that I would like random sentences to be handled. I actually use randomly generating sentences here in order to, I use grammars. You can see here in some of my my code here. It does actually use I can, if I put, for example, something like say related semantic analysis grammar. This is going to produce, say, a few hundred random sentences. Actually, yeah. If I have random sentence generation, I can do quite a lot of other things, right? And so, yeah, faster regex matching, then quite a lot of things are going to be faster. All right, so I would like, as a conclusion, I would like to mention that, yeah, I do see some of this being used definitely as web services and as a learning tool. I do want to make this type of conversational agents and working on basically on this too. I'm working right now. Actually on this free. I'm not working on the crew scheduling. And I am writing a book called Raku for Prediction, in which many of these topics are going to be spelled out. Sorry, we're out of time, but I can take a question or two. I'm not sure. I'm not hearing any feedback, but I did for Daniel's Sockwell. I did prepare this this part here with the tries. How I'm using tries to generate grammars, and this is another thing from Unix. We actually, one of the principles, we try to generate write code that generates code. So similarly here, I've been using say tries to generate Raku grammars. Then at some point I decided actually I would rather be doing this through resources, resource functions, and so forth. But anyway, I did have several engagement comments like that. Jonathan Worthington, he was mentioning that writing the comma I8 was very you need to plan for failure, and so similarly here in this parts we need to plan for failure. Okay, and I know we're over time, but I'm not sure, not hearing any feedback.
Anton, I had a quick question. Hi, this is Bill Michaels. Great presentation.
Thank you.
I only have a technical question, and that is Shiny Apps, as far as I understand, is fairly limited on as many, how many concurrent users it can accept. I think maybe it's 800 to 1,000. And so technically, I would have thought you would have gone for something like Crow or a web framework in Raku and then built around that. I'm only using, you're seeing this part here. This is running on the DigitalOcean server with Crow and Raku, right? So if I show you my code here, right, for this, it's, sorry, just located here. It's, so somewhere here, right, in my level, I lost it. But anyway, somewhere on this, you can see that I'm using Crow for this, right? I mean, I basically start the process. I have this routing and etc. Right? This is what is running on the DigitalOcean server, right? So this is what interfaces these packages. I'm only using Shiny Apps. If I show you the code here, I'm on, or not, I guess. I'm only using Shiny Apps to connect with the web service, right? I mean, I really hope. Yeah, right. I really hope. Yeah, well, maybe that's a conversation we could have some other time, whether there's some sort of frame buffering that you're doing there. It's just, it's out of my expertise. So, but now I say I understand you're showing us the raw Shiny code.
Yeah, you can see the translation here. This is what is the, I make the call to Crow, right? And I get this translation. This is just a easy way for me to make a web interface.
I see.
It's like, seriously, I really want, I mean, I explicitly put this button to share code, but anyway, whatever. So any other questions?
Great. Thank you.
Thank you. Somebody mentions more detailed example. Fine, maybe I can do that. I want Greek protein and fat lunch. So I'm going to evaluate this. So this generates some code, right? And then this code was executed, and you can see this recommender here. Most of this, say, Greek cuisine and fat, right? And also protein and whatnot. So, I mean, it's more or less going through, it does know a certain utilization history of meals and user inventories and so forth, right? So I'm using a meals recommender in order to make this, to generate the code, and then I execute it. There's some, I mean, you can see, for example, here, like say there's some introspection modules, right? Which I need to remove this user because it's empty. But yeah, I mean, I can see, I do have some other commands which can facilitate all this kind of full-blown food preparation agent.